I want to present about Precom Girder. Precom means Prestressed Composite Girder. Firstly, the concept. Many types of prestressed composite girder have been used in Korea. Generally, prestressed composite girders consist of steel eye girder and bottom concrete which envelops lower flange of steel eye girder. To prevent tensile crack in bottom concrete, prestress applies to the girder, using post-tension or preflection. The reason prestressed composite girders are usually used in Korea is the lowest girder height. The lowest girder height can make larger clearance for traffic and flood. The Preflex is the oldest type prestressed composite girder. In order to pre-compress bottom concrete in Preflex girder, the steel beam is pre-deflected and then the bottom concrete is cast. After it has sufficiently hardened, the beam is unloaded and the concrete becomes prestressed. Preflex technology was introduced in Belgium and Japan around the 1950s and then adopted in other countries such as Germany, Great Britain, and South Korea. But it has several disadvantages in economics and constructability. Precom is one of prestressed composite girder and most commonly used in Korea recently. Precom girder has two key points to overcome disadvantages of general prestressed composite girders. One of them is hanging form and the other is effective tendon arrangement using dead anchorage. Due to them, Precom needs less amount of steel to be economical and no hazardous process such as preflection and works in high place. Hanging forms are used for the steel eye girder to resist self-weight including the bottom concrete. Therefore, there is no stress in bottom concrete by self-weight. The left side computer graphic shows the mechanism of hanging form. Yellow box means steel eye girder. As this graphic, when bottom concrete is cast with hanging forms, the deflection of steel eye girder will be occurred. After strength of bottom concrete reaches 14 megapascal during a day or so, even if the hanging forms are removed, there is no stress by self-weight in bottom concrete because the supporting conditions remain unchanged. The second key point is about tendon arrangement. Generally, the stress in center of span is much larger than end of span. So effective tendon arrangement can be achieved by using dead anchorage with bulb bond head of DeWitt. Compared to the both ends, twice as much pre-stress is applied in the central part of the girder. Due to the first key point, necessary amount of pre-stress reduced to 70%. And with dead anchorage, the live anchorage force could be reduced to 35% of other girder. These two key points of Precom make a lot of advantages. First of all, total amount of pre-stress is reduced by self-weight. Girder can be isolated from fabrication device before compressive force for pre-stress applies to bottom concrete. Therefore the fabrication device can be used to make a next girder. More girders can be fabricated faster with a limited number of devices. There is no need to rush to apply pre-stress because isolated girders do not occupy the fabrication device. Reduced period of high compressive stress status or jacking at older age bottom concrete could minimize the long-term loss of pre-stress. There is no worry about compressive failure of concrete when jacking force for pre-stress is applied. Fabrication procedure is simple. The segments of eye-shaped steel girder are made in factory with limited length for transportation. After transportation from factory to site, the segments are assembled by welding in the field. The assembled eye steel girder is set in simply support condition. Reinforcements, ducts and anchorages are placed as design. And then the hanging forms are installed on steel eye girder before pouring inside to concrete for bottom concrete. Generally, the design strength of bottom concrete is 45 megapascal. For the initial strength of concrete, 8 hours steam curing is performed. and then the fabricated girders are placed in storage space until pre-stressing time is determined considering erection schedule. This period could be from 2 weeks to several years. During this period, concrete gets age and creep coefficient of concrete gradually decreases. After pre-stressing and grouting, the girders are transported to the erection site. After erection, the cross beams and deck are constructed. Produced on this schedule, the loss of pre-stress due to the long-term behavior of concrete is reduced, as it not only minimizes the period of high compression stress status affecting the creep but also diminishes the creep coefficient. Next, about carried experiments about Precom. Several static and dynamic experiments were performed. In 2005, before Precom is applied to actual bridge, real-scale tests are performed for 3 single girder specimens and a 2 girder specimen. The static and dynamic performance of Precom are identified for actual bridge. After that tests, Precom is applied for several real bridges. Because there is no 45-meter railway bridge of pre-stressed composite girder before 2011, the static and dynamic experiments were carried out for 45-meter real-scale specimen. For similar reason, 50-meter real-scale experiments were carried out about general type in 2014 and about advanced type in 2015. The steel web of Precom is covered by concrete, which is not considered as structural member in normal type Precom. But in the advanced type of Precom, steel web is exposed with stiffeners and painted. The third picture of this page shows the normal type and the loss picture shows the advanced type. We call this type as light Precom. Mock-up tests of Precom in lab were carried out before all important events. And after all important events, field tests for actual bridges were carried out. In 2005, the field test for the first Precom bridge. In 2007, the field test for the first railway Precom bridge. In 2007, the field test for long-term performance. In 2009, the field test for the first Raman-type Precom bridge, and in 2020, the field test for the first advanced-type railway bridge were carried out. To identify the long-term behavior of Precom, data of actual bridge for 4 months were measured and analyzed. About design and BIM of Precom. We have our own design program that can be applied to various design conditions with graphic user interface. Design methods such as allowable stress method and limit state method can also be selected. Every information for bridge design can be inputted by GUI or text input. This design program has been used and updated for over 10 years. With this program, we can check the safeties at each construction stages and material quantities. We can get PDF documents of calculated results through design program. It also consider the limit state and long-term behavior of composite girder. The design for long-term behavior is based on the age-adjusted modulus method called AEMM. This method is adopted through analysis actual bridge data for 4 months as previously mentioned. Nowadays, we have been trying to develop BIM for Precom. Precom is not complex structure, but there are so many things to consider. Basically, the shape of steel and concrete, the arrangement of tendons should be modeled, and in order to improve accuracy, details such as camber and longitudinal design profile should be considered too. These two models show camber model and straight model. This map shows the basic algorithm about BIM of Precom. Much amount of data have to be inputted about basic materials such as steel girder, rebar, tendon and concrete and check the relation. They are connected each other for arrangement considering the space, cover and distance between each of them. Inputted data from Excel program of MS Office are automatically connected and check. as the order of fabrication. Steel eye girder is modeled first, then rebars and tendons are added. In third step, the bottom concrete is modeled. As mentioned previously, the cover of concrete and distance are important data. This graphic shows parameter simulation. As you see, graphic model is modified automatically in real time by inputting numbers for camber, length, thickness and etc. This page shows about steel eye girder modeling. There are two sections basically whose widths and thicknesses of flanges are different. The data for transition zone is essential information too. As you see in lower part of this page, in present model, we named them as Section 1, Section Change and Section 2. Additional members could be inputted also. To simulate accurately the longitudinal profile of girder, various data have to be considered. Various data means design profile, deflections due to loads and long-term behavior of girder. Some of them must be calculated for each fabrication stage. The structural members are generated along an alignment and cross-section of each member always perpendicular to the alignment. The location of change zone also must be inputted. All informations about rebars and tendons in previous two-dimensional design are made available. We are trying to ensure that all information on rebar and tendon in the previous two-dimensional design can be inputted, and planning to improve the accuracy, for example lap joints of rebar. About bottom concrete, the basic shape and blockout for anchorage could be inputted. The concrete cover of rebars and tendons have to be considered from in step 2. The ages of concrete according to construction procedure have to be considered. Currently, BIM of Precom is between LOD, level of details, 200 and LOD 300, therefore there are many things to improve the levels. We will continue to improve BIM of Precom. The last thing I want to show you is how to use Precom and its application cases. Precom can be used in bridges crossing roads or rivers. Due to lowest height, Precom can make more space below bridge or reduce the amount of embankment. It is useful in many cases to make a large space under the bridge. When a vehicle passes, it is freer from the height limit of traffic and relatively free from the flood level when the stream passes. In case the clear view is important, the Precom bridge is the best option too. Precom girder can be fabricated with various upper line profiles. As these pictures show, the more clearance could be secured while meeting the design requirements. The upper picture shows about single-span bridge case, and the lower picture shows about 3-span bridge case. The girders in these bridge have different height along a longitudinal direction to create a beautiful view or a larger space. Totally over 700 Precom bridges are constructed during 15 years in South Korea. Cyprus Bridge in Jeju Island is the first Precom bridge. The longest span length is 50 meter as railway bridge, 60 meter as roadway bridge and 62.3 meter as pipeline bridge. Currently the longest Precom railway bridge, with no concrete cover on the web of the steel girder, that is so-called Precom Light. Precom has been used as a 40-meter railway bridge for more than 10 years and is expanding its span to 50 meter. I want to finish my presentation by showing the actual Precom bridges. This bridge, so-called half-moon type Precom, features a variable girder depth from mid-span to both ends. This type is usually installed over rivers and streams, because it is easy to make bridge clearance high for preventing from flooding. The next bridge shows connecting two islands for the resident, with the middle two spans higher than the others due to ship passage. This bridge has a length of 60 meters, the longest roadway bridge of pre-stressed composite girder bridges in Korea. Incheon International Airport Passenger Terminal 2 began construction in 2009 and opened in 2018. There is Precom below the plane's runway, with a total length of 85 meters long. It features design to resist the load of the Boeing 747 A380. Hongwon Bridge is the first roadway bridge fabricated as Precom Light. The bridge crosses four-lane highway where large cargo trucks frequently pass. Its web of the steel has no concrete cover, that is helpful for workers to construct concrete slabs safely and rapidly. Sungsan Bridge is the same as Hongwon Bridge. Looking like concrete, the web is sealed with gray color actually. The absence of concrete takes its weight lighter than normal Precom. Originally this site was supposed to construct with PSC beam, but its heavy weight makes difficult to transfer and install the structure. This is why Precom Light was built instead of PSC beam. Next shows the Precom railway bridge built with totally 6 span. And each span length reaches 40 meters. Dagok 4th Bridge was uncommon as railway bridges with a length of 40 meters using the pre-stressed composite girder at that time. This case is a railway bridge made of Precom Light, connected with the arch. On the opposite side, Precom Light with the same girder depth as PSC beam is connected with a series of PSC beams. Its length is 50 meters long, which is the longest Precom Light railway bridge up to now. Finally, if building the bridge over the railway in use, construction lap time is set from midnight to dawn. In this case, the rapid construction is demanded such as prefabricated or precast concrete methods. This Precom Light pedestrian bridge is spanned of 23 meters long and was used full-depth precast concrete decks in order to make efficient works in a short time. As a result, it makes whole construction period earlier. Thank you for your attentions.